Hi there, in this tutorial I'll try to explain Newton's second law along inclined planes. Knowing that friction force is neglected, the only two forces acting on this object is the normal force and the gravitational force. We must specify the direction of the acceleration. Since this object will be sliding along the downward direction, then A will be downward. Let's choose the coordinate system. For our case, either we can take x upward and y perpendicular to x, or we can choose x along the direction of motion. Next, we will try to project or find the components of each force. As you can see, N is acting along the y direction only, while mg is acting along x and y. To find the component of each force, we must know the angles. As you can see here, angle theta is given, and this one is 90 degrees. The remaining angle will be 90 minus theta. So if this angle is 30 and this angle is 60, the remaining angle here will be 30. So both of these angles will be theta. Now we can replace each force by its components. So instead of writing mg, we can find mg along x and mg along y. For now, I'll provide the direct solution for this projection. Later on, at the end of this tutorial, I'll provide an explanation. So for this case, to find mg along y, we must multiply the force by cosine theta. Here, to find mg along x, we must multiply mg by sine theta. To recap, if the angle theta is given, you use cosine. If the angle theta is not given or not written, you use sine. Now we'll apply Newton's second law along the y and the x direction. As you can see, along the y direction, the only forces acting are the normal force and the mg cosine theta, which is the mg along the y direction. But since this object is not accelerating along the y, then A along y will be equal to 0. Then sum of the forces along the y direction will be equal to m times A, which is 0. Finally, n, which is positive, and mg cosine theta, which is negative, add up to 0. Then we can find the normal force. Now let's try to project Newton's second law along the x-axis. And along the x-axis, the only force acting is mgx, which is mg sine theta. Then we can write the sum of the forces equal to m times a, and along the x direction, mg sine theta plus 0, since the normal force is not acting along the x, equal to m times ax. Finally, the acceleration along the x-axis will be equal to g sine theta. Now, concerning the cosine and sine angles, let's take this figure. As you can see here, we have mg, and this weight or this gravitational force is made up of two components, one along the x and the other along the y. And let's take this triangle, knowing that sine theta will be equal to opposite over hypotenuse, while cosine theta will be equal to adjacent over hypotenuse. So once we use the sine, it will provide us with the x component, while once we use the cosine, it will provide us with the y component.